This is Doug Vahrenberg, and welcome back to another set of tips and tricks. And today we're going to talk about Vahrenberg electronics and what it takes to power our units. We've got these big bad boys, and there's a lot of people that come to me and have questions and concerns about them. And one of the things that I find out resolving a lot of their problems is the power supply to it. The power supply is a very critical component as far as how well the unit can perform. A unit that is underpowered may only be able to power part of the features of what you've got in the unit. The Vahrenberg power cable comes with the unit, and you can connect that direct to the battery, or in like the case of this boat, we're farther away at the console than we are from the battery supply. And even if we run a bow unit, we need to go back to those same batteries in the back of the boat. So it is very critical to allow that unit to have the proper power supply. And one of the analogies I like to talk about is comparing water to electricity. Electricity, basically, you've got voltage and you've got current. Voltage can be consistent through any size wire, but current, it is dependent upon the wire size that you have. So the larger the gauge the wire, the more current you can supply, and the better your Vahrenberg unit can perform. The same thing goes for a common garden hose versus a fire hose. Look at this garden hose and the amount of water that it can pump out compared to this image of a fire hose. They can both develop the same amount of pressure through pumps or the water supply, but the amount of current or gallons per minute in the case of water, a fire hose can supply more gallons per minute than a garden hose can. So if your house was on fire and you were inside, would you rather the fireman use a garden hose, or would you rather him use a fire hose like he has to help extinguish the flames so they can get you out safely? I hope nobody has that happen, but that's the same analogy that we use in electricity. Is the amount of current is very important to our units. Our voltage is also very important, but as long as we have a good connection, and I recommend using soldered connections, a blade style fuse versus a glass bulb style fuse, and there's a lot of components in a proper power supply that goes into it. If you look, we have a little bitty wire right here. The gauge compared to that one is a lot smaller. This wire gauge is smaller than this gauge, and we can get bigger gauges here. Look at the size of that wire. That's getting bigger, and this is getting bigger than that. And we can even get a little bit bigger wire gauge here. And this is a trolling motor wire to run our Minn Kota trolling motor. This wire can supply more current, but it's still only going to supply 12 volts if you only hook it to one battery. Now we have 24 and 36 volt systems on our trolling motor. That is only for the amount of basically pressure is our water analogy versus electricity is our voltage analogy. Voltage and pressure are very similar in the two different types of system we're talking about. But do you think that wire and this wire can supply the same amount of current? They can both supply 12 volts, but this wire is going to supply more current. Now, Vahrenberg engineers recommend 18 gauge wire if you need to extend. And if you look at this picture, it'll show voltage drop over distance. Now, one of the things about voltage and current is a lot of boats wiring systems. This is my new Skeeter here. The wire supply in here is fresh and new. They use heavy gauge wire to power the electronics and stuff, and it's usually ample if you want to connect into that system. But I'm going to caution, if you have older boats, you have a boat manufacturer that has smaller gauge wire running to the console that you're going to try to tap into, may not supply enough current. So that's why Humminbird and myself recommend running them to the batteries to get your power supply, so you have a good clean power supply that is adequate for your needs to operate the electronics and operate it to the level that it needs to be. This wire here isn't going to be enough to supply enough current to operate your electronics. I recommend 14 to 16 gauge wire. If you go to your auto parts store or whoever's going to supply your wire, if you look at the cost difference between 18 gauge and 14 or 16 gauge, there's not a lot of difference. We don't need this big a wire to supply our electronics. But if you bump it up, it's going to help improve and give you a lot longer life of your power supply. Because if you think of that same water, and if you had hard water, what's it do to piping? Have you ever looked inside of a pipe and noticed that in hard water we have basically hard water deposits or calcium deposits? Those deposits, there's the same thing, similar thing that happens in electrical wiring. What happens in electrical wiring is heat. As electricity is transferred through that wire, basically you're supplying here and it's applying electricity through this wire. It actually heats the wire, and if you feel older wires, they get hard and brittle. And what that is from that heat that is developed through electricity. It's in small minute amounts in most situations, but it creates a resistance in the wire. Or you get a little bit of corrosion. If you look at this, the blue or the green looking stuff, that can get inside your wire if you use like a butt connector, you don't have a good sealed connector. That's why I like to solder my connections, heat shrink them, and have a good, especially in a marine environment, have a good power supply that is trouble-free. These are just tips to get you the best power supply and the most trouble-free power supply in your boat. So we don't need 6 or 8 gauge wire, but anywhere from 14 to 18. If you know you're going to keep that boat for 4, 5, 6 years and you don't want to have to redo your power supply due to possible resistance in the wire or corrosion that gets in the wire that reduces the amount of cabling you have, this basically, or the size of the hole like in a pipe, do a 14 or 16 gauge and it's going to be plenty for you. It isn't going to cost you any more money, and it's going to allow the unit to have more current than it needs to properly power itself. And remember, Humminbird recommends a 3 amp fuse, and I would recommend putting that back at the batteries to provide protection for your unit. You can buy a multimeter like this at the hardware store, the automotive shop, and what it allows you to do is you have voltage readings, amp readings, ohm readings, but what we're concerned about is our voltage reading. What we want to do is go to that 20. That's going to be 0 to 20 volt readings. And what we've got here is our connectors. And I've just set up a little test unit here to show you how easy it is to test your voltage with a Humminbird. We've got it running right now. I'm just going to power it down. And we can pull the power plug from the unit here. And if you look at the Humminbird power plug, we have 2 openings here. We can actually take our probes and stick them in here and test our voltage readings. So I'm going to put that one in here, and I'm going to put this other one in the bottom hole, and it didn't come back. That's because I had reversed the polarity, or the positive and negative. Now, when I plug in, I've got 12.44 volts. If you look at this chart here, it's going to show you the state of charge of a battery. That state of charge is going to show the voltage at the battery, not at the unit or down the wire. 12.44 is a good reading for voltage, but you've got voltage under load. When we're using our units, we're pulling power. We're basically sucking that juice out of that power supply, and we're using some of it. What you can do is we can take our unit, and if we plug this cable in, if you don't fully plug it all the way in, if you see here, you plugged it in, there's just a little bit of gap. My probes are just a hair big. You may have to remove your cable from the cable collector to perform this, but we can turn our unit on. I've got just a simple 12-volt battery. This is the same thing that you could be doing on your boat to show power supply. I'm going to hit menu, going to hit exit here, and we're going to hit menu, and I'm going to go into simulator, and I'm going to hit exit, hit menu, go over here to setup, which is our wrench and our screwdriver symbol. I'm going to come down, I'm going to be in advanced user mode, and I'm going to go down here to select readouts. And I'm going to go down here on this unit, I can put it across the bottom. And I'm going to go to number 6, and I'm going to put voltage. I just want to compare voltage versus my reading I got. I'm showing 12.1 volts. We had 12.4. That would be our voltage under draw. What the unit is using to power the unit is going to be shown up right here. Now, one thing I can do is I can take this unit, and with my multimeter, I'm going to pull it out just a hair there so I can get to those power supply wires. And I'll try to set this back up here again. And be very careful since I'm just plugged in here. I put that in there, and we don't have our reading, so got to remember to get the right positive to the right side. Now we're at 12.25. That's pretty close to 12.1, but that is showing from my 12.44 was my straight voltage. I'm down to 12.25 with a draw from the unit. The unit is powered, as we can see there, and I was getting a little less. That is going to be a way to test your voltage under draw. If you have inadequate sized wiring, you're going to lose voltage over that distance that the wire is. Plus, you're also going to lose current. So that is an easy way to test that you're getting a proper power supply to your unit. The other thing is it's harder to simply test current amp draw, but that is a quick little test that anybody can do. These multimeters are great little tools. They're very cheap. I think I paid $10 for this one. I can test batteries. I can test my unit power supply. I can test a wide range of things. You can even test household electricity with them. Thank you for tuning in to another set of tips and tricks. And I hope that helped you learn a little bit more about electricity and the importance and the critical part of a boat. I mean, we power our outboards, our trolling motors, our electronics. We use good Minn Kota battery chargers to keep it up in shape. But if you skimp on supplying your unit with an improper power source, the unit is only as good as the installation. Don't skimp on your wiring. Don't skip on your transducer install. Do it right the first time, and you'll get a lot more enjoyment and more time on the water, so you can go out there and catch that fish of your dreams or lifetime, or win that next tournament. Thank you, and tune in next time as we go more in depth in the products I use and how to use them and how to do them and how to rig them right. Thank you, and tune in next time.